Hello and welcome to another exam paper walkthrough. Thank you for joining me. Today I'm going to be looking at a GCSE maths paper and I'm going to be focusing on an AQA past paper. If you're doing another exam board, it's still great revision. I often revise with other exam boards. It gives you a different range of questions, but still pretty much the same skills. Um, the paper I'm focusing on today is from June 23, and this is a 2H. So this is a calculator higher paper. In the description of this video, you'll find a link to a Google Drive where you can download a copy of the paper. It will look like that. It's just got my QR code on the front. And I would strongly recommend that you either have done the paper before watching the video or you do the paper alongside the video, pausing and having a go at a question and then pressing play and seeing how you would do that specific question. Hope you find this useful. I would also recommend a bit of music on in the background. I tend to have a bit of music on when I'm listening to these via an ear pod. It just makes me find them a little bit more enjoyable. Hope you find this useful. If you do, please do subscribe if you like. Right, before I get into the paper itself, what I'm going to bring up is this advanced Q&A. So this is a breakdown of the paper by question, and it is some data from the students that actually sat it. This includes kind of an idea for grade boundaries, from the mean mark achieved by grade, and it also gives you this really useful, depending on how deep you want to look at it, question facilitated by grade. So typically speaking, the grades get progressively more challenging, so you find students did exceptionally well on the first few questions, and then it gets progressively less of the greens. And it also gives you some really interesting data on sort of anomalies, questions that stumped students that were not expected. So for example, this is a good one. Question 14 part D, appropriate types of average caused was one of the more difficult questions. Actually, I think it was the students did the worst on that specific element overall. That's just quite useful. It gives you an idea behind the paper. Anyway, we shall crack on with the paper itself. Okay then, so question one, write 30 to 12 in the form n to 1. All we really need to do is divide both sides by 30 here. Sorry, divide both sides by 12, I'm doing it the wrong way around. Divide both sides by 12. And I think that's going to give me 2.5 to 1, so 2.5. Question 2, 4 consecutive triangle numbers are, write down the next triangle number. So triangle numbers, if you've not come across them, they form triangles. So each time we're adding an extra row, we're adding an extra 1. So this is going up by 4, this is going up by 5, this is going up by 6. So we need to do 21 plus 7, which will give us 28. Right. Question 3, write the reciprocal of 4 over 7. So the reciprocal of 4 over 7, we flip the numerator and the denominator over, or you can say what do you need to times that by to get 1. And you can kind of see that in a more visual way. So it's going to be 7 over 4. I'm sure you could get away with 1 3/4 there, but I would tend to go for 7 over 4. Right, question 4. The price of a toy increases by 12.5% too. So if it's increased by 12.5, that would have been the original price multiplied by 1.125, and that would be equal to 19.53. So n is going to be equal to 19.53 divided by 1.125. Right, let me bring in my calculator. So I'm using 991 EX emulator. If I do anything on there that might be different to standard or other options, I will go through it. 125 equals. The modern calculators don't have this SD button. You have a format button here. You press format and decimal. 17 17.36, so £17.36. Okay, question 5. Jess saves 2p, 5p, 10p coins. She has 45 10p coins, 8 times as many 2p coins as 10p coins in bold. £17.70 in total. Work out the total value of 2p's to the total value of 5p coins, giving your answer in its simplest form. Right, so if we start with 2p's to 5p's to 10p's. Right, if we start with the number first of all, and then we'll do the value afterwards. So we've got 45 10p coins. We're told that there are 8 times as many 2p coins as 10p coins, so we need to times that by 8. So 45 times by 8 gives us so 360 2p coins. So I'm going to go to the value now. So we've got £4.5. We've got 7.2. So 360 times by 2 is 720, which would be £7.20. So we're told the total value of all the coins. So I'm going to do £17.70 minus 7.2 plus 4.5. So that's going to be 17.7 minus 7.2 plus 4.5 gives me 6. So we've got £7.20 to 6. Right, so I want this. Where are we? The total value. So in effect, I want this ratio in its simplest form. So I'm going to say, to be fair, I can simplify this directly with my calculator. So if I do 7.2 over 6, that will automatically simplify it down to its simplest form, which would be 6 to 5. So 6 to 5. Okay, question 6, part A. So, part of a regular polygon is shown. Assuming that the polygon is an octagon, work out the size of the exterior angle. So we want it's drawn on it for us. So that's going to be 360 divided by the number of sides, which is an octagon would be 8. So divided by 8, which would give us 45 degrees. Right, part B. In fact, the polygon has more sides than an octagon. What does this mean about the size of the exterior angle? Well, that means that we're going to be dividing by a bigger number here, so we would have a smaller number here. So it is less than my answer to part A. Right, question 7. In a game, an ordinary fair spinner an ordinary fair 6-sided dice is rolled and a fair spinner is spun. And the fair spinner shown is spun. Okay, so we've got expressions here. The score is the dice number substituted into the spinner expression. Okay, complete the table for all possible outcomes. So 2x means times in these values by 2. So we're looking at 2, 4, 6. 8's already done for us. 10 and 12. 3 lots times in these by 3, so 3, 6, 9, 12, 15, 18. And then squaring them, so 1 squared 1, 2 squared 4, 3 squared 9, 4 squared is 16, 5 squared is 25, already done for us, and 6 squared is 36. Okay. Right, part B. A player wins the game if their score is 10 or more. Work out the probability that they win the game. So we have got 3 times 6 outcomes. So is the number of outcomes, and then the probability is going to be the number of wins. Was it 10 or more? 10 or more. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So 8 over that. Which is going to give us 8 out of 18, which would be 4 out of 9. But I don't think you need to simplify it. So, and then part C, the game is played 711 times. Estimate the number of games that are won. So we're doing 711 times by 4 over 9. So 711 times by 4 over 9. So 316 times we would expect the game to be won. Question 8. So quite a complicated expression is identically equal to work out the values of A and B. Okay, so looks complicated, but in effect it's just saying that is going to be equal to that, and that has got to be equal to that. So A minus 3 must be equal to 5, so A must be equal to 8, and then 2B must be equal to 12, so B must be equal to 6, so 8 and 6. Right, question 9. So A is 1, 3, B is 2, 9, points on a centimetre grid. ABCD is a parallelogram. AD and BC are horizontal, and each has a length of 5 centimeters. The diagonals AB and CD crossed at E worked out 2 possible pairs of coordinates for E. Okay, so if we're told we could have A could be over here. No, sorry, D could be over here or over here, and then B, E could be AD, BC. C could be over here or over here, roughly. And then the horizontals are going to be the midpoints. Okay, so yeah, let's actually put where they would be on. Horizontal and each have a length of 5. So if we could just go, that could be there, and 2, 4, 5 could be there, and then 2, 4, 5 could be there, or could be 2, 4, 5 could be there. Okay, so okay, let's assume that we've got this one first of all. Obviously not drawing this particularly well. Right, so this would be E here, and I'm just trying to check that so the distance between these two is actually 4, so that would be the point there. So let me just explain that more. So let's pretend that I've not got the diagram, and let's just include the coordinates. So C would be at the point minus 3, 9, and D would be at the coordinate of minus 4, 3. So the coordinate, the x coordinate is going to be halfway in between 3 and 9. So halfway between 3 and 9 is going to be 6. So I've done that the wrong way around. So if I look at my x coordinates first of all, it's going to be halfway between 1 and minus 3, which would be minus 1, 3. Sorry, not 3, 6. Again, I'm looking, let's say, I've written, I've made a mistake there. That should be -1. So let's actually do the sum for that. So that x-coordinate is -3. So we want -3 plus 1 divided by 2 is going to be equal to -1. And the other one I want halfway between 3 and 9. So 3 plus 9 divided by 2 is equal to 6. For the other one, this point would be at 7, 9. And this coordinate would be at 6, 3. So first of all, my y coordinate is still going to be at 6, but my x coordinate now is going to be halfway between 1 and 7. So 1 plus 7 divided by 2 is 4. So those are my two possibilities. Okay, question 10. Write down the translation vector that maps A onto shape B. So A onto B. So we're going from here to here. We're going to go across and down. We've gone across 4. And we've gone down 3. So the translation vector would be 4 minus 3. Okay, question 11. So volume of a sphere. Bowl is a hemisphere of radius 12. Water is poured into the bowl at a rate of 325 centimeters cubed per second for 8 seconds. Does the water fill more than 70% of the bowl? You must show your working. Okay, so the volume, I'm only going to work out 70% of it. So that's going to be 0.7. So to work out the total volume of 70% of it, I'm going to say that that volume is going to be equal to a half of 4/3 pi times 12 squared cubed times by 0.7, which is going to be 2/3 times by pi times by 12 cubed times by 0.7. So the total volume is going to be 2/3 times by pi times by 12 cubed by 0.7. So I will type it all like that. First of all, 32 over 5 pi. And it's a decimal, that's going to give me 2,533.3. But we change pen color just to help me out here. So the liquid is being filled at that 8. So I want to do 325 times by 8. So 325 times by 8 gives us 2,600. So that's the amount of liquid. That's 70%. So does the water fill more than 70%? Yes. 2533.38 centimeters cubed is less than 2,600 centimeters cubed. Okay, question 12. Show these two rectangles are similar. So to do that, all I'm going to say is if I look at the common sides, so 5 over 8, and then 12 over that. So 12 over 19.2. So this one is obviously in its simplest form already. So 19.2 is equal to 5 over 8. So similar. Corresponding sides. same scale factor. Could have gone decimal there, but I think that's absolutely fine. Okay, question 13. A factory packs X boxes of tea bags per hour. Each box contains 80 tea bags. Show that the factory packs 40X over 3 tea bags per minute. Okay, so they're gonna so if I go number time. So in 1 hour, they would pack 80X tea bags. The 1 hour is 60 minutes. So that means that they pack 80X in 60 minutes. So all I've done is convert my hours into minutes. So that means that that's 80X over 60 in 1 minute. So we've divided by 60 there. Put that there as well. So that is 80 over 60 is 4 over 3. So that's 4x over 3 in 1 minute. So 4x over 3 a minute. Okay, question 14. A company has 123 employees. Information about their hourly rate of pay is shown in the table. The owner of the company uses this data to make 2 statements. Statement A, over 30% of the employees have an hourly rate that is more than £17. Statement B, the average hourly rate of pay is more than £20. Show working that supports statement A. Over 30%. Okay, so I'm going to look at the number, an estimate for the number that are less than 17. Then £17 first of all. So if I look at midpoints of these groups, just because it works out nicely, midpoint of that group is 17. So in effect, that's going to be half of this group. So 32 divided by 2 is equal to 16. So we can make the assumption that 16 plus 66, so 16 plus 66 is going to be equal to 82. So let's just double check that. Yeah, so we can make the assumption that 82 out of the 123, sorry, people are paid more than £17 or £17. So that's going to give us 82 divided by 123 is equal to so 66 2/3%. Low 17. So 100 minus 100 minus 66. Right. Let's do that again. So 82 divided by 123 is equal to that times by 100. That's my percentage. So 100 minus that is going to be equal to 33.33 above 17. So over 30% of the employee rate more than 17, so 33 and third percent above £17. So that average supports that statement. Why might statement A not be true? So the distribution in this group might not be an even split. So the distribution of the, was it 14 to 20, 14, 20, put the right letter in the middle, P. Inequality symbol the wrong way around. May not be an even split. Each side of 17. Work out an estimate for the mean to support statement B. Right, so I started filling this table in. I'm going to carry on with my mid values. So midpoint of this value is going to be 12. Midpoint of this value is going to be 25. Midpoint of this value is going to be 70. So I'm going to times these together and add them up. And then I'm going to put that figure there. So 66 times by 12 plus 32 times by 17 plus 25 times by 15 plus 70 times by 10. Let's just check the figures there. Out the ordinary, that looks right. So 2411. So my estimated mean is going to be 2411 over 123. And I've typed it in that way so I can actually write this down. So my estimated mean is going to be equal to 2411 divided by 123. So 19.6016. So dot dot dot. So that's going to be 19.60 pounds. Right. I've just spotted this group here is not right. My midpoint here should be 30, not 25. So I'll change my number here. Let's redo that calculation. So I'm changing that value there to 30. So 2486. So 2486 over 123 should be my actual value. So that number and then that value. Right. 2486. So I should have had 20.21138 dot. So 20.21. Okay, part D. Why is the mean not the best average to represent this data? So let's have a quick look at the data. So I mean, the majority of people earn far less than that. So it's been negatively impacted by the high earners. So so the mean has been affected by by the few people who have a very high hourly rate. Okay, question 15. Expand. So x squared times by 2x would give us x cubed. X squared times by 5y would give us 5y, 5x squared y. Minus 9xy times 2x would give us minus 18x squared y. And then minus 9xy would give us minus 45 y squared. So we're going to have 2x cubed minus 13x squared y minus 45xy squared. Okay, so question 16. Line A has an equation of y is equal to ax minus 1 and passes through the point 713. Line B has equation 5y minus 3x is equal to 4. Show that line A has a gradient greater than line B. Greater gradient than line B. Okay, so if we start by working out the gradient of this line, so we can work out the gradient because we know the intercept, we know a coordinate on there, we just don't know the gradient. So when x is 7, y is equal to 13. So 13 is equal to 7a minus 1. So 14. So 2 is equal to a. So put a there. So a gradient 2. Right, line B. So we need to rearrange this to get it in the form y is equal to mx plus c. So 5y minus 3x is equal to 4. So 5y is equal to 3x plus 4. So y is going to be equal to 3 over 5x plus 4. So B gradient 0.6. So line A greater gradient. Right, question 17. Work out the size of angle X. Right. Okay, so I'm going to work out this angle here. This angle here, I'm going to call it y for now. I'm going to say y is going to be equal to 180 minus 90 plus 37. So that's going to be 43. No, 53. Just check that there. 180 minus 90 plus 37. 53. Yeah. Okay, and then I'm going to use the fact that sine x over 4 is going to be equal to sine y over 9.3. So sine x would be equal to sine of 53 divided by 53 divided by 9.3 times by 4. So I'm going to go straight to x then, is going to be sine to the minus 1 of that. So shift sine, type it in as it appears. So sine 53 over 9.3. And then I want to times that by 4. So that's going to be 20.09020 dot 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 dot. So I'm going to say 20.1. Okay, question 18. Rearrange to make x the subject. Right, so we've got x appearing twice, which is nice. So my first step then is going to be to multiply both sides by x. That would give me xy is equal to x plus 8. And they're going to take all parts containing an x and factorize over here. So y plus y. So xy minus x is equal to 8. Then factorize y minus 1. And then divide by that factor. So 8 divided by y minus 1. So x is going to be equal to 8 over y minus 1. Question 19. Here are the first 4 terms of a quadratic sequence. Work out an expression for the nth term of the sequence. Okay, quadratic sequence, it's the second differences that's going to give us our value. So that's going to be 17, 27, 84 minus 47. So it's 37. So we've got a constant difference here of 10, 10, and 10. So that means that this second differential is 2 lots of n squared. So that means that we've got to have a... That's not quite right. So that means that our second differential must be 10 over 2 n squared. So we're going to have 5n squared. So if I start by looking at 5n squared, so, and then slightly differently. So if I say my values for n and then my values for 5n squared, 1, 2, 3, 4. So that's going to be 5, and that's going to be 4 times 5, that would be 20, that would be 5 times 9, which would be 45. Sixteen. 16 times 5, 18. Right, if we look at the actual sequence, the sequence was 3, 20, 47, and 84. And then if we look at the difference, so we've got a difference of between the sequence. I want to find out what we need to add to this. So we've got minus 2, 0, 2, and 4. So that means that sequence would be 2n minus 4. So my sequence is going to be 5n squared plus 2n minus 4. So 5n squared plus 2n minus 4. Right, let's just double check that by the table function. I think 8, no. So I'm just trying to get used to this calculator. There we go, 9. So 5 5x squared plus 2x minus 4. I don't want a second function. I want to start at 1. That's fine. So that gives us 3, 20, 40. Yeah, that works. Okay. Question 20. So P, Q, and R are points on a circle. S is a point inside the triangle of PQR. Assume that S is the center of the circle. Work out angle X. So assume that S is the center of the circle. So S is the center of the circle. Work out the size of angle X. So it would be half of that, so 130 divided by 2, which would be 65. Okay, in fact, the center of the circle is on PS, but not at S. What does this mean about the angle? So that would create a bigger angle there. So my answer would be larger. It is greater than my answer to part A. Okay, for a different circle, AB is the tangent at A. C and D are on the circumference of the circle. AC and CD are equal. Here is Simon's method to work out the size of angle Y. Angle ADC is equal to 70 degrees. And it's segment theorem. Therefore, angle Y is equal to 70 as it's an isosceles triangle. Is he correct? Give reasons for your answer. No, he's not correct. No. Angle ACD would be equal to 70. Not angle ADC. Okay, question 21. Morgana decides to put £500 into an account that pays compound interest. She wants to have at least £560 in the account after 3 years. Work out to one decimal place the minimum annual interest rate she needs. So we want £500 times by 3 to be equal to 560. So we want x cubed to be equal to 560 divided by 500. 28 over 25. So we want to cube root both sides. So cube root 1.0. I should have put some inequality symbols in. I'm going to put them in now. So we want her money to be greater than, at least, so greater than or equal to, greater than or equal to, greater than or equal to. It's one decimal place, so that's going to be 3.84 ... So we need at least, so 3.9%. Right, question 22. An approximate value to the root of the equation x can be found using the iterative formula. Starting with x is equal to 4, work out the value of x2 and x3. Right, so I'm going to put 4 in first of all. Then I'm going to go cube root of 5 lots of my answer. squared minus 2 lots of my answer minus 3. So I've got 4.10156593 and then 4.177641648. By continuing the iteration, show that the value of x is more than so essentially I just need to keep pressing the equals until I get a value and show that the value is going to be over 2. Continuing the iteration, show that the value of x is more than. So, I mean, well, let's carry on. So that's 3, 4, 5. So x to the 5 is equal to 4.2757 dot 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 dot, and x to the 6 is equal to 4.30345. So it must be greater than 4.25. We've shown two values that are both over 4.25, so it will just continue bouncing between these, getting more and more accurate. There we go. Okay. Question 23. Here are 3 sets of cards: set A, set B, set C. In a game, a player has 2 options. Option 1, pick 2 cards from set A. Option 2, pick 1 card from set B and pick 1 card from set C. The card is picked at random. The player wins if the total of their 2 cards is exactly 10. Which option gives a better chance of winning? Option 1 or option 2? Okay, so from option 1, the only way that we can make 10, because actually, if you look at this, the only way that we can make 10s is by one of the 5s. So the probability of getting a 10 would have to be picking one of the 5s the first time, which would be 3 out of 2, 4, 6, 8, 2 out of 8. And then the second time, there aren't 3 5s the second time, there are only 2, and there aren't 8. There are only that. So that's going to be 3 over 7. So the probability of picking, no, 3 over 28, sorry. 3 over 28. Right, the other options are a bit more tricky because we could, so there's no option that would work 1 or a 2. We could have a 4 and a 6. We could have a 6 and a 4. We could have, those are my only options. So it's got to be one of those 2. What about one of those 2? So it's got to be 1 over 7. So we could have either picked the 4 and then the 6, which would be, so option 2. We could have probability of a 4 and then a 6, which would be 1 over 7 times by 1 over 4. And then there's the probability of a 6 and then a 4, which would be 1 over 7 times 1 over 4. So that's going to be 1 over 28 and 1 over 28. So 2 over 28. I'm going to leave them as 28. Could simplify that down, but which option gives the better chance of winning? Option A, option 1. And then that's my working up there. Okay, question 24. So A is equal to 65 to the nearest integer, B is equal to 30 to one significant figure. Work out the upper bound for, you must show your working. So we want the 2 times A max squared minus, if we want the maximum, we want to take away the minimum value. So B minimum squared. So that's going to be 2 times by to the nearest integer. So the smallest, the maximum that could be would be 65.5 squared minus the minimum that could be would be 25 squared. Okay, so we're looking at 2 times by 65.5. Don't really need the brackets around there, but minus 25 squared. So 7955.5. Okay, 25, show that simplifies to where. Okay, right. So I'm going to say that x minus 5 times by x plus 2 plus x plus 5 times by x minus 2 divided by x minus 2 times by x plus 2. Okay, so the first part's going to give me x squared minus 3x minus 10, plus the second part's going to give me x squared plus 3x minus 10. And then that's the difference of 2 squares, so that would just be x squared minus 4x minus 2 squared, which would be minus 4. Right, so that's going to give me 2x squared. Those would cancel, so minus 20 over x squared minus 4. Okay, and question 26, final question. Here is a sketch of y is equal to x squared. The minimum point of y is equal to x squared is at 0, 0. Write down the coordinates of the minimum point of x squared plus 2. Okay, so that just means that all of the y coordinates would be shifted up 2, so that would be 0, 2. And part B, the graph of y is equal to x squared is reflected in the x-axis. So reflection in the x-axis becomes, if we've got y is equal to f of x, reflection in the y-axis becomes y is equal to minus f of x. So write down the equation of the graph after this transformation. So y is equal to minus x squared. Describe, so y is equal to x squared is now transformed to give y is equal to x plus 3 squared. Describe fully the single transformation. So likewise, if y is equal to f of x, then y is equal to f of x plus 3 would become a translation in the x-axis of minus 3. So we are looking at translation. minus 3 in the x direction, so of minus 3, 0. Okay, and that's the end of the paper. Right, so I'll bring up that question analysis again. Okay, so again, this kind of gives you an indication of the grade boundaries for that paper. It gives you kind of an idea of what sort of grade you're at if based on how well you did on that paper. It also brings back into play this question facilitated by grades. And again, those few stumbling points mid-paper. So I hope you found that useful. That also gives you the opportunity, if you struggled on the question 26, it gives you the topic transformation of graphs if you want to do some independent revision. The chapters in this video will be referenced to these topics. If you want to get directly to a specific question again, just to look at it, feel free to do that. I hope you found that useful. Thank you very much for your time in listening. If you've got any questions, comments, or feedbacks, please drop them into the chat to this video, and I'll get back to you fairly quickly with a response. And if you've found this video at all useful, please do subscribe if you like. Good luck, and I will see you soon.